6 hours ago, your last bottle of clean water ran dry. The stream in front of you is brown, sluggish, and moving with things you'd rather not look at too closely. Now picture reaching into your pocket and pulling out 2 thin strips of metal. One copper, one zinc. You twist them together and drop them in. No pump, no battery, no chemicals. Just 2 metals touching, doing something they've been doing since before anyone wrote down what chemistry even meant. Stick with me, because by the end of this, you'll know exactly how to build a real, honest version of the system yourself. And just as importantly, where its limits actually are. Because in a survival situation, the difference between those 2 things can matter more than almost anything else. Here's the question worth sitting with. If a few dollars of scrap metal can do something meaningful to dirty water, why is the global water purifier industry worth tens of billions of dollars a year, built almost entirely around plastic cartridges you have to keep buying every couple of months? That's not a rhetorical jab. It's a real economic question, and we're going to answer it with chemistry, history, and business logic, not guesswork. Let's go back about 4,400 years, to the banks of the Nile. An Egyptian field healer is treating a soldier with a deep spear wound. In this era, the wound itself rarely killed you. Infection did, and infection usually rode in on water. The healer reaches for a copper vessel, fills it with river water, and waits. He has no idea what a bacterium is. He just knows, from watching it happen over and over, that water kept in copper behaves differently than water kept in clay or wood. This observation made it into the Smith Papyrus, one of the oldest surviving medical documents on Earth, which explicitly recommends copper for sterilizing both wounds and drinking water. About 2,000 years later, Hippocrates wrote about copper treating leg ulcers. Greek sailors noticed that water stored in wooden barrels turned foul within days at sea, while water kept in copper containers stayed drinkable for weeks. Rome scaled the idea into infrastructure, running copper pipes into their aqueducts. And on the other side of the planet, with zero contact with any of these civilizations, Aztec healers independently arrived at the same conclusion, using copper-treated water as a throat gargle. In India, Ayurvedic tradition still recommends storing water in copper vessels, a practice called tamra jal, followed in millions of households today. 4 civilizations, thousands of miles and years apart, all noticing the same pattern without ever comparing notes. That's not coincidence. That's chemistry, waiting patiently to be noticed. Then, the Industrial Revolution happened. Copper was expensive, plastic was cheap, and chemical chlorine could disinfect water at a scale no metal ever could. The old knowledge didn't fail. It just got quietly filed away in favor of mass production. It resurfaced almost by accident in 1984 when a researcher named Don Heskett dipped a brass pen refill into a glass of chlorine-tinted water during an unrelated experiment. The pink chlorine color simply vanished. Brass is copper and zinc together, and Heskett had just stumbled onto something real. He spent years refining it and patented the process as KDF, kinetic degradation fluxion. It's genuine technology, still used today, NSF certified, sitting inside shower filters and pre-treatment systems worldwide. Here's the actual science, and it's simpler than it sounds. When copper and zinc physically touch inside water, they form a galvanic cell, basically a tiny battery, with the water acting as the connecting bridge. Zinc is an unstable metal that wants to shed electrons. Copper is happy to receive them. That electron flow does 2 things reasonably well. It helps convert dissolved chlorine into harmless chloride, and it draws some dissolved heavy metal ions toward the metal surface, where they get trapped through a process similar to electroplating. It also creates a mildly hostile environment for some bacteria, which is the same effect Egyptian and Greek observers were noticing without knowing why. Now, people often bring up NASA to make this sound more dramatic than it is, so let's be precise. For the Apollo missions, NASA engineers built a 9-ounce device that used electricity to actively push silver ions into the crew's water supply, killing bacteria without chlorine. It's a brilliant piece of engineering, and it is related to the same broad family of metal-based antimicrobial chemistry, but it's a powered, active system using silver, not a passive copper-zinc pair sitting in a jar. Conflating the 2 overstates what 2 twisted wires can actually do, so I'm not going to do that here. So why haven't you heard more about the honest version of this? Not conspiracy, just business. The water purifier industry is worth tens of billions of dollars annually, and the real profit engine isn't the device, it's the replacement cartridge. A KDF-style copper-zinc treatment can last years and never needs replacing, which makes it a poor fit for a subscription-shaped business model. That's an incentive problem, not a cover-up, and it's worth understanding either way. Now for the honest, practical part, the part where Hidden Fix Lab earns its name. Copper and zinc are a genuine supplementary tool, not a magic wand. They will not reliably kill everything in truly contaminated wild water, and they do essentially nothing against parasites like Giardia or viruses like hepatitis A. So the real rule, especially with any water whose source you don't trust, is this. Boil it first if you possibly can. 10 minutes at a rolling boil kills essentially everything that matters. That's the actual safety net. once your water's already reasonably safe. Or if you're just dealing with strong chlorine taste from a tap, here's how to build the historical version as a genuine improvement layer. Buy a length of bare 14-gauge copper wire and a strip of zinc from any hardware store, a few dollars total. Cut both to about 12 inches, twist them together tightly so the metals are in direct contact, and drop the pair into a covered container of your water. Overnight is plenty. In the morning, remove the metals, rinse them, and they're reusable for months. If you want to go further, pack natural hardwood charcoal into a container with a drainage hole and run your water through it. It pulls out organic compounds and residual taste that the metals don't touch. For the most stubborn threat, food-grade diatomaceous earth made from fossilized microscopic algae physically traps particles as small as 1 to 2 microns, including parasitic cysts, too tough for any chemical or electrical process to handle. 4,000 years ago, someone paid close enough attention to notice that copper changed water. In 1984, someone else noticed the same thing happened to a pink chlorine solution. NASA built on a related idea to keep astronauts alive. None of them had the full picture, and neither do we, completely. But paying attention to what's actually proven, instead of what sounds impressive, is what turns folklore into something you can trust with your own safety. That's the real lesson here, more than any single trick. Know exactly what a method can do, know exactly where it stops, and never let the second part get lost chasing the drama of the first.